Welcome to Mrs. Merkel's Trig class. Let's start with a prayer. In the name of the Father, and the Son, and the Holy Spirit. Amen. Ave Maria, gratia plena, Dominus tecum, benedicta tu in mulieribus, et benedictus fructus ventris tui, Iesus. Sancta Maria, Mater Dei, ora pro nobis peccatoribus, nunc et in hora mortis nostrae. Amen. In nomine Patri et Filii et Spiritus Sancti. Amen. Okay, another week. Let's get started. Today we're talking 8.5, the remainder theorem. So let's take a look and see what the remainder theorem says. All right. So if we have polynomial p of x, so p of x is going to be our polynomial. Okay. Then we know the remainder theorem says that p of x is equal to q of x times x minus c plus p of c. Okay, so what that means is, so p of x is our polynomial, q of x is our quotient, x minus c is our divisor, and p of c is the remainder. No need to panic. This actually gets a lot easier when I show you an example, okay? So let's take a look at an example and I'll show you where all of this goes, okay? So let's say that p of x is equal to x to the fourth minus 14x squared plus 5x minus 3. And they are going to ask you to find p of negative 4. Okay? So what you do for this is important, okay? So here's the thing. We're going to find p of c, okay? c is negative 4, all right? What you have to notice is that this here is here, okay? So what we're gonna do is, so this is what the question is going to look like, all right? And we're going to find p of negative 4. So what we're gonna do is we take that negative 4 and put it in the box, like that, okay? So that's p of c. So negative 4 goes in a box, okay? We're gonna do synthetic division, okay? So we have to be careful. Remember, when you're writing these equations down, if you have a missing term, you must fill in with the missing term. We're missing the x to the third term. Whenever you write the, whenever you're doing your homework, if there's a missing term, don't even write it like that. Write it as x to the fourth plus 0x cubed minus 14x squared. Otherwise, you'll forget. So let's take a look. So we have x to the fourth, so which is 1. So x to the third, we don't have that, so that's 0. Minus 14, 5, and negative 3, okay? So let's take a look here. We'll bring this down, okay? That's 1. 1 times negative 4 is negative 4. Add those up. Negative 4 times negative 4 is positive 16. We'll add those up. 2 times negative 4 is negative 8. Add those up. You get a negative 3. Negative 3 times negative 4 gives me a positive 12. And negative 3 plus 12 gives me 9, okay? So what we can tell from this is that p of negative 4 is equal to 9, all right? Now, if you remember before when we did functions, when we had to find p of negative 4, what we had to do is we had to take that negative 4 and substitute it in every single place that we found, because p of x is negative 4, so every time we see an x, we would put in negative 4. So let me show you, if you do this correctly, okay, I'm going to show you this. Look how much easier this is so cool, okay? So let's try now to find p of negative 4 the way that we used to do it. P of negative 4 is equal to x to the fourth. So what that means is negative 4 to the fourth power minus 14 times negative 4 squared plus 5 times negative 4 minus 3. Okay, anything raised to an even power will be positive. 4 to the 4th power is 256 minus 14. Negative 4 squared is 16 plus 5 times negative 4 minus 3. Okay, so we have 256 minus 224 minus 20 minus 3. You put all that into your calculator and you get P of negative 4 is equal to 9. All right, so what do you think? Which way do you think you have more careless mistakes? This way, where you could possibly have a sign mistake, or this way, it was much easier, okay? So the remainder theorem is really cool for finding the functions, okay? Let me do another example so that you can see it. And then that'll be what your homework is like. Let's see here now. I had a piece of paper here. Let's see if I can find it. There it is. Okay, let's take a look. I am on page... Oh, I have to tell you something else too. There's another name for the remainder theorem, and it's actually much more appropriate. The remainder theorem is also called synthetic substitution. Okay, if you want to find P of X, make X your C, and find the remainder. Using synthetic division. Okay. So another name for the remainder theorem is what we say called synthetic substitution. Okay, let's take a look at page 375. Let's see what one of these looks like. We're only going to do one of these because these are actually really cool and they're not too hard. Let's take a look at 375, number 8. Number 8 says, use synthetic substitution to find P of C for the given polynomial P of X and the given number C. So they give us that P of X is equal to 2x to the 4th minus 3x cubed plus 3x squared plus 1. Now, be careful. I'm not going to write just plus 1 because, look, the x term is missing. So I'm not going to copy it out of the book exactly. I'm going to put in that missing term immediately so that I don't forget it, okay? Then plus 1, okay? So, and they said, given that C is equal to negative 1/2. All right, so we're going to use synthetic substitution. So we take our negative 1/2 and we put it in the box. We write this down. So we have 2, negative 3, 3, 0, and 1. All right, bring this down, okay? 2 times negative 1/2, positive times a negative will give me a negative, all right? Negative 1. So negative 3 plus negative 1 gives me a negative 4. Negative times a negative gives me a positive. 4 times a half gives me 2. 3 plus 2 is 5. 5 times negative a half is negative 5 over 2. 0 plus negative 5 over 2 gives me 5 over 2. Okay, now 5 over 2 times a half. First of all, you can use your fraction key on your calculator, that's fine, but we have a negative times a negative, which is a positive. We multiply the numerator, so 5 times 1 gives us 5, okay? And 2 times 2 gives us 4, all right? So now it's 1 plus 5 over 4. We need a common denominator, so we're going to make 1 into 4 over 4. So it's 4 over 4 plus 5 over 4, which would be 9 over 4. So your answer is, because they're asking you, they're finding, use synthetic substitution to find P of C for the given polynomial. So what we're going to say is that P of negative 1/2 is equal to 9 over 4. And that's your answer. Box that. Okay, And that's all you need to do for synthetic substitution. They're going to give you C, put C in the box, use synthetic division, and that is your answer. P of negative 1/2 is equal to 9/4. If you were so inclined, you could put this 1/2 in here, but look at how much work that would be. You would have to put 1/2 to the 4th power, 1/2 to the 3rd power, 1/2 squared. It would get really confusing. So this is actually really cool. All right. Okay, now there's a corollary to the remainder theorem, which is called the factor theorem. And I'm having trouble with my sheet here. It's not turning over. Okay, so the factor theorem says, there's second thing that we're going to do today. The factor theorem says, if P of X has X minus R as a factor, if and only if R is a root of the equation, P of X equals 0. Okay. So what this means is it has no remainder when you divide. And substitute R into P of X, you must get 0. This is the factor theorem stated, but we need to go over a couple of examples. And the really cool thing is this works for all numbers, real and irrational and complex. That would be imaginary. So that's why we're going to have some really cool answers, really cool problems for our homework. So let's take a look here, and we'll go over a bunch of these because they're fun. I know it doesn't make sense. Trust me, it'll make more sense when we put it into an example. All right. Let's take a look. I am on page 375, and we're going to take a look at number 10. All right, so we're going to use the factor theorem. So 375, number 10 says, use the factor theorem to determine whether the binomial is a factor of the given polynomial. All right, so they give us, it looks like this. It says t plus 1. That's the factor that we're determining, okay? T plus 1, and the polynomial is P of t is equal to t to the 5th plus t to the 4th plus t cubed plus t squared plus t plus 1, okay? So we're going to use the factor theorem to determine whether this binomial is a factor of the given polynomial, okay? So how we do that? So when remainder theorem says if P of negative 1 equals 0, then yes. There's something under my paper causing me a problem. Okay. I wrote this out every time. So if P of negative 1 is equal to 0, then yes, this is a factor of this. Okay. So let's take a look. What does that mean? What that means is that now we actually do need to use that everywhere we see t, we're going to put in negative 1, okay? So let's take a look. So we have negative 1 to the 5th power plus negative 1 to the 4th power plus negative 1 to the 3rd power plus negative 1 squared plus negative 1 plus 1. Okay, so let's see if P of negative 1 is equal to 0. So negative 1 to the 5th power, an odd number, a negative raised to an odd exponent will be odd. So negative 1 to the 5th power is negative 1. When you raise a negative number to an even power, it'll be a positive 1. Okay, when you raise a negative 1 to an odd power, it'll be a negative 1 plus negative 1 plus 1. All right, let's take a look and see what we got here. Negative 1 plus 1, that's 0. Negative 1 plus 1 is 0. And negative 1 plus 1 is 0. So your whole total for all of that is 0. So what we found that P of -1 is equal to 0. So yes. All right. What that means is that it says to determine whether the binomial is a factor of the given polynomial. So what that means is that this here, t plus 1, is a factor of this. This goes evenly into this with no remainder. All right. Let's take a look at number 12 because number 12 is kind of cool. Let's see here. Number 12 says z plus 2. And our polynomial is P of z is equal to z to the 5th plus 2z to the 4th plus z cubed plus 2z squared plus z plus 2. Okay, so now what we need to do, if P of -2 equals 0, then yes, okay? This is opposite, so you have to remember, we'll go over this at the end, but if this is +2, this is -2, okay? So let's take a look. So we're gonna say P of -2. So we have -2 raised to the 5th power plus 2 times -2 raised to the 4th power plus -2 raised to the 3rd power plus 2 times -2 squared plus -2 plus 2. All right, so let's take a look here. Number 12, it says, so 2 to the 5th power is equal to 32. So we have, this is -32 because a negative raised to an odd power will give us a -32 plus -2 raised to the 4th power. So that's going to be positive, because all those, they're going to line up. So that's going to be -2 to the 4th power is 2 times 2 is 4, times 2 is 16, times 2 is, no, 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, 2 to the 4th power is 16, 16 times 2 is 32. Okay, plus 2 to the 3rd power is 8, and it's -8. Plus -8 plus -2 squared is 4. 4 times 2 is 8 plus -2 plus 2. So let's see what we got here. So we have -32 plus 32, -8 plus 8, and -2 plus 2. That is 0. So that is yes. The answer is yes. All right. That wasn't as cool as I thought. The next one is going to be cool. Let's take a look at number 14. Because remember how I said this works for irrational numbers as well? So number 14 says we have t plus the square root of 2. And our polynomial is P of t is equal to t to the 5th plus t to the 4th plus 4t plus 4, okay? T to the 5th plus t to the 4th plus 4t plus 4, and this is t plus the square root of 2. So if P of negative square root of 2 equals 0, then yes, then it is a factor, all right? So what we need to do is we need to find P of negative square root of 2. So what that means is we're going to take negative square root of 2 and we'll raise it to the 5th power plus negative square root of 2, raise it to the 4th power plus 4 times negative square root of 2 plus 4. Okay, so let's see what we got here. So square root of 2 raised to the 5th power. So first of all, we know that it's going to be negative. But let's see what it is. We have to write it out here because, I mean, you could actually be easier to put it in your calculator, but let me show you real quick what it is. The square root of 2, 1, 2, 3, whoops, 4, and, oh my gosh, 5. That's a mess. All right, let's do it like this. 1, 2, 3, 4, 5. Square root of 2 times the square root of 2 times the square root of 2 5 times, okay? Square root of 2 times the square root of 2 is 2. The square root of 2 times the square root of 2 is 2. So we have an extra square root of 2. So this raised to the 5th power is 4 square roots of 2, okay? So we have negative 4 square roots of 2 plus, okay, so now this is going to be positive because it's a negative number raised to an even power, but we're only going to have 4. So take a look. It is 2, square root of 2 times the square root of 2 will give us 2. Square root of 2 times the square root of 2 will give us 2, so your answer is just 4. Okay, then it says plus, okay, 4, negative 4 square roots of 2 plus 4. Okay, so let's see what we got here. So here's the problem. The signs don't work. 4 plus 4 is 8. See, this is close, and they try to make them look close to try to trick you, okay? 4 plus 4 is 8, and negative 4 square roots of 2 plus negative 4 square roots of 2 would be negative 8 square roots of 2, okay? So when you add all of this up, no, this is not a factor. Okay, but the cool thing is that you can work with irrational numbers. Now, let's take a look at number 16, and that'll be our last example, and I'll give you your homework. So, let's take a look here, number 16. So this is kind of cool because it gives us some review on irrational numbers and complex numbers, because take a look at number 16. Number 16. Number 16, we have, this is z plus 2i, and p of z is equal to z cubed plus z squared plus 4z plus 4. And they want to know if this is a factor. So what we do, we need to know, is p of negative 2i equal to 0? Remember, you have to change the sign there, okay? So I don't know. Let's take a look. So we have negative 2i raised to the 3rd power plus negative 2i raised to the 2nd power plus 4 times negative 2i plus 4. Now, with what you remember is that I squared is equal to a negative 1. Okay, but let's take a look, because we have got to see, we got to take this one at a time. So negative 2i to the 3rd power is the same thing as saying negative 2 times itself 3 times. Okay, so let's take a look and see what we have here. A negative 2 times a negative 2 times a negative 2, that would be negative 8. Okay, negative times a negative is a positive. Positive times a negative gives me a negative. 2 times 2 is 4. 4 times 2 is 8. Okay, so now I squared, I times I would be I squared. So that's a negative 1. And the last I is there. So the answer to this is 8i. Negative 2 raised to the 3rd power is equal to positive 8i. This is actually the hard part, is just getting these straight, okay? So negative 2i squared, so let's write it out. Negative 2i times negative 2i, that is equal to, negative times a negative is a positive, so that would be 4. I times I is I squared, so that's a negative 1. So 4 times negative 1 is negative 4, okay? The next one is 4 times negative 2i. 4 times negative 2 gives me negative 8i. Okay, and your last one is just 4. Now, we can add these vertically so we don't have to rewrite them, but take a look at this, all right? So we have, oops, I made a mistake there. Plus 4. Oh, yeah, no, that's right. Sorry about that. Okay, so let's take a look. So we have 8i minus 8i and negative 4 plus 4, and we get 0. So yes, that is a factor, okay? So what you have to remember, which I wrote down here somewhere, where did I write it down? That, okay, when you're using the remainder theorem, and like they say c is equal to negative 5, then negative 5 goes in the box, okay? But when you're using the factor theorem, let's say you have x plus 1, it's the negative one that goes in the box, okay? So it matches exactly for the remainder theorem, but for when you're using factor theorem, you have to take the opposite of it. That's going to be where you're going to go. And then the first one, you're using synthetic, and the second one, you're using this, where you plug it into here, like f of x or p of z or whatever. So try those. I will have an answer key, and I will send that out if you're having any questions on that. Your homework is page 375. Number 1 to 15 odd. That's it for today. All right. I will see you tomorrow. Have a nice night. God bless.